to start, if you agree.
Hello, good morning, Julia. Yeah, yes.
Good morning.
Okay, so yes, nice to meet you. Yeah, Professor Holin is ready, so the floor is yours.
It's forum.
Okay.
Let's begin. Okay. Ladies and gentlemen, welcome to Carbon Neutralization and Green Shipping Forum today. I'm Li Yinghao from Dalian Maritime University. It's really a great honor to chair this forum today. First, let me introduce today's speaker, Julian Reina, who is the Dean of the Faculty of the Sea and the Environment of Universidad del Pacífico, Ecuador. He is the former Vice Chair of the Intergovernmental Oceanographic Commission, UNESCO. He was former Secretary General of the Permanent Commission for the South Pacific. And he was also a retired Navy officer from the Colombian Navy. Now, his research interests are ports and coastal engineering, ocean policy, scientific research into tsunami, ELNIO, and ocean pollution. His topic today is improving carbon neutralization and green shipping in Ecuador and some other countries in IOA. Now, let's welcome Julian Reina.
Thank you very much, Lillian. Well, I'm ready to start. I'm going to share my presentation.
Okay.
Please confirm me that you can see it.
No.
Now, maybe?
Yeah. That's okay. Now we can see it.
Okay. There we go. Okay, thank you very much. Again, I have the opportunity to share with you tonight this information that I hope you can find it interesting. Is for me has been a lesson to study again all these issues that are related to pollution, to contamination. And I would like to start exactly, but talking about that, talking about ocean pollution or pollution coming from ships. And sorry, gonna move this a little bit. And when I have this in mind, I necessarily need to start to speak or to think about MARPOL, which is the Maritime Pollution Agreement of the International Maritime Organization. And there are different spaces dedicated in this document. And one of those is the Chapter 6, which is related exactly to our contributions in gases that could be nocive to humanity. And the IMO says that although air pollution from ships does not have a direct cause and effect associated with, for example, an oil spill incident, it causes a cumulative effect that contributes to the overall air quality problems encountered by populations in many areas, and also affects the natural environment, such as stop acid rain. This is stated by IMO in 2021. And okay, here we go. What is stated in the Annex 6 of MARPOL is that it was first adopted in 1997 within the limits of the main air pollutants contained in ships' exhaust gases, including the sulfur oxides and nitrous oxides, and prohibits deliberate emissions of ozone-depleting substances, ODS. And MARPOL 6 also regulates the shipboard incineration and the emissions of volatile organic compounds, which are the VOCs from tankers. And following entry into force of MARPOL Annex 6 on 19 May of 2005, the Marine Environment Protection Committee, which is the MEPC, at its 53rd session in July 2005, agreed to revise MARPOL Annex 6 with the aim of significantly strengthening emission limits in light of technological improvements and implementation experience. As a result of 3 years of examination of this chapter, the Annex 6, the MEPC 58 in October 2008 adopted the revised MARPOL Annex 6 and the associated nitrous oxides Technical Code 2008, which entered into force on 1st of July of 2010. So this is exactly what are related with our speech today, coming from IMO directly from MARPOL. In this slide, you can see in the x-axis the years from 2010 to 2050, and in the y-axis you can see the amounts of kilograms of CO2 by container. So I'm going to try to explain it the easiest way, is that if you see from 2030, which is right here, the emissions in red keeps more or less constantly until 2050. So what is the impact that we are looking now in the world in general? I mean, not Ecuador, not Latin America, but in general, is to try to reduce until 2015 the emissions of CO2 from the shipping sectors. Not all the countries are obliged to have this time lapse to reduce their CO2 emissions. I mean, countries are free to set so, but they can go also to 2060 or to 2070 or to 2080, depending on the capabilities of the country and the political decisions, the money, the budget that is dedicated to it, etc. So, but in general, as I say, is like from 2030 to 2050, more or less, the world is expecting to stop the gas emissions of CO2 to the atmosphere. Then, obviously, because the fleet is growing up, should be some more gases in the atmosphere. But those other gases, which are the orange and the greens, are, for example, the orange are emissions reduced by ships, energy efficiency management plants. And the greens are emissions reduced by energy efficient operational indicators. So, in general terms, the image shows us that until 2050, we can keep very reduce the gases that could be nocive, could be dangerous, and they don't need to grow up beyond that point that we reach in 2030. Now, there is another point here and is what causes these kind of gases to the human health. And I'm going to try to explain first the image at your right. It comes from different gases in natural gases, like, for example, from volcanoes, or human-produced gases, like the coal plants, for example, or from mining. All these gases are coming from the atmosphere and rains into the ocean, or are carried down by the stream of rivers into the ocean too. So all this kind of mercury that is loaded into those gases are coming into the ocean, and the krill consume them. Then every species that consumes the other species, the other minor species, is going to be like growing and growing and keeping more and more mercury in their organism. So we start by krill eating mercury in small quantities, but then salmon and oyster consume krill, and then the trug and tuna consume the salmon and pollock, and then finally the shark, pike, or albacore, or halibut are consuming the trout or the tuna, and the amount of mercury that keeps in the flesh of these kind of big fishes, well, it's very, very dangerous for the human health. And this is what it comes here, saying that mercury becomes a problem. The human activities, however, are responsible also for this. The quantity of mercury released by watering processes is approximately 230 metric tons per year. The quantity of mercury released by burning of coal is estimated to be in the order of 3,000 tons per year, a quantity comparable to that emitted as waste from industrial processes. And the fossil combustion is the main cause of mercury emissions. The UNEP assessment says that concentration of mercury in the top 100 meters of the oceans has doubled in the last century, and estimates that 260 tons of the toxic metal found its way from land into rivers and lakes. UNEP publishes in 2018 the Global Mercury Assessment, and this is, as I already showed in the last slide, that is completely related to our topic today, that emissions from artificial and small-scale gold mining, which is the ASGM, account for almost 38% of the global total, and the area contributions of emissions from South America and Sub-Sahara Africa. Human activities have increased total atmospheric mercury concentrations by about 450% above natural level. So this is really dangerous and really important topic to keep it in mind. The climate change also has changed the terrestrial and aquatic ecosystem processes, and is playing increasingly important roles in this cycle of mercury. So it is affecting also the distribution of the gases that we send to the atmosphere, and the different processes of scattering of these gases, and obviously the consumption of them in zones that probably are not directly contaminated or polluted by these gases. The assessment also underscores that all people are exposed to some amount of mercury through, for example, consumption of fish, or shelling, or marine mammals, as I already explained it in the last slide. And the assessment refers to mercury as the chemical element in all forms, in contrast to the Minamata Convention. You know, in the Minamata Convention, they distinguish mercury from mercury compounds. But in this assessment of UNESCO, they are talking, when they say that they are having into account the mercury. They are talking to mercury as the chemical element in all the forms. So for all this pollution, IMO designed a greenhouse gas strategy in 2018. And the strategy has two objectives to help achieve the temperature goals set by the Paris Agreement. It is all related. We have been seeing now the MARPOL, the mercury assessment, and now the IMO GHG strategy. And all this is related to climate change. So it's like we cannot separate one topic from the other. Everything is all together. And the two strategies that have been designed by IMO are first, reducing the total annual GHG shipping emissions by 50% by 2050 as compared to 2008 levels. That is the graphic that I showed you with the ship with containers. And the second strategy is phasing out the shipping emission as soon as possible in this century. To achieve these goals, IMO will work in three impacts. These three impacts are declining the carbon intensity of ships with the help of Energy Efficiency Design Index, EEDI, to decline the carbon intensity of international shipping, and for the greenhouse gases emission from the international shipping to peak and decline. To accomplish with this strategy, IMO needs a data collection system, obviously, to understand what is happening with the ship industry and to bring all these numbers to the desired ranks in the strategy. According to the system, the owners of large ships, which are above the 5,000 gross tonnage, have to report on fuel consumption of their ships. What is happening in Ecuador with these plans, with these international plans? What is happening with IMO in Ecuador? Well, you're going to have a speech a day after tomorrow by Sandra Asanza, which is one of our professors. And she's going to explain exactly what is happening in Ecuador. But now, I just want to give you some idea of what is happening. There are two great strategies in the world, which are the mitigation work program and the adaptation work program. All these two programs are thinking to determine contributions to national levels. And that is where Ecuador enters and adopted these international strategies. This national level is known as NDC. And there are two kind of incomes into these plans, into these projects at the national level. One is the conditional part, and the other one is the unconditional part. So one of those depends on the money, depends on the International Association, and the other one is what can we do by ourselves. So when we try to bring all these together, the international help, international financiation, and what can we do internally, we can go to this zero carbon national program. This is what we are doing now, and it is exactly what Sandra Asanza will be talking to you 2 days after. But I have to say something about Latin America, and this is, okay, what is happening with the country that has more flag vessels in the world, which is a very, very small country called Panama. And you can see it here in this pie, in this dark blue zone is Panama. Panama has the biggest fleet in the world, but is a very, very small country. So when you start to see the numbers, it is almost doubling the second flag country, which are the Marshall Islands. And the average vessel size is not as big, but the deadweight tonnage is really important. So we have here an idea that I want to share with you, and I would like you to think a little bit about it. What happened when you start to point out to a very small country to be responsible for the pollution of the air in accordance with international regulations, IMO regulations, etc. If they are really a small country that doesn't produces any, or not any, but very, very few CO2 emissions. And all these ships are coming from other countries, and they are in Panama because they have the convenience flag. So we start to see that it's not that perfect, the system, to start to point out who is responsible for the pollution in the world, especially in this field of the shipping industry. And I want to compare these two graphics. In the left one here, you can see how big Panama is compared with other countries by flagships. But we don't have any other country, no one from Latin America, different than Panama. So there are some other countries that are big enough, very strong too, but no one is Panama. And in the right side of the slide, you can see in the big dots, like these ones, who are the countries that are with bigger amounts of CO2 to the atmosphere. In this part, in this region with the arrows, you can see then Costa Rica, Panama, which is this very small dot here, Ecuador is this one here, and Uruguay, which is this small, very small dot here. And why I am noticing these countries specifically, because Costa Rica, Panama, and Uruguay are the countries that are, and Chile also, which is, let me show you Chile. Chile is right here, are the countries that are working in controlling the air pollution by ships, or in general, by CO2 to the atmosphere. So again, Costa Rica, Chile, and Uruguay are countries that has plans for reducing CO2 emissions to the atmosphere. Panama is responsible legally because it is the major flagships in the world, but Panama doesn't produce almost anything in CO2. They don't have very strong industries to produce it. And Ecuador, yeah, it's a little bit bigger than Panama, but not much either. So here you have this general view of what is happening in Latin America. This is the wealthy nations lead per capita emissions. We start by Saudi Arabia, US, and Canada, just to mention the first three of them. And in the first 15, we don't have anyone from Latin America. Then coming to the Panama Canal information, we can say that the Panama Canal aims to become carbon neutral by 2030. It was announced officially in April 2021, just recently. And however, it began tracking its carbon footprint in 2013 with the intention of better aligning its operation to the global objectives of reducing emissions to mitigate and adapt to climate change. The Water Bay bolstered these efforts with an innovative idea in 2016, promoting green transits through the Green Connection Environmental Recognition Program and by creating an emission calculator in 2017, a tool that not only allows shipping lines to measure the greenhouse gases emissions per route, but also strengthens the canal analysis of the emissions produced by its own day-to-day operations. Yeah, obviously the tow ships and other logistic boats are contributing to CO2 emissions in Panama, but not as much as the other ships that are transiting the canal. This is the general steps that have been crossed through by the United Nations. And I just bring this slide because they have a very nice title here. They say if the decarbonization is an utopia or it's a new green wave. That sounds very interesting. It gives us the opportunity to think a little bit more about, not just to point out X or Y country, but to think a little bit what is really happening with this. I constantly said that there are like fashion weeks within the world system, and sometimes the tragic events cause them. For example, tsunami in 2004. There was like a great wave. Everybody has to talk about tsunami. But in 2010, almost the whole world forget about tsunamis and start to talk about different things. Now it's like the fashion week of plastics. Everybody has to talk about plastics. And that brings me to this question of how is that ships start to be into the aim of these programs? Because as far as I can remember, ships weren't that kind of pollutants in the world. But okay, let's continue watching what is happening. In this image, you can see also from FAO 2022 how these three countries that I already mentioned, Uruguay, Chile, and Costa Rica, are the only three countries that are right now into the world plans already with policies. As you can see here, this block from yellow, light yellow is or are the countries that has policies at least. The other ones upper are with laws or more advanced systems, and the dark yellow are like a little bit later talking about policies. But in general, in Latin America, in summary, we have three countries that already has policies about the decarbonization. In this map, we can see here a data from European Commission that show us the moving of the ships around the world and the countries where those ships are stopped for more time or more frequently. So you can see these countries lighter than the other ones. And again, we start to notice that it's important in the in the northern hemisphere, how these countries are more involved in pollution by CO2 than in other countries in the southern hemisphere. So there are 6 ways to reduce ship emissions, which are using cleaner fuels such as LNG. Slow streaming and route optimization will consume less fuel. Using renewable energy, modifying parts of the ships to increase energy efficiency, utilizing battery stored energy, and avoiding empty container reposition. Yesterday, Professor Minji Chu were giving us some information about this that results very interesting, and for sure it's coming in one of these 6 ways to reduce emissions. Well, the first one is switching to green fuel. In the graphic, we can see how, again, until 2050, we'll start to reduce these gray color gases, which is to become with cleaner gases, which are the green ones. And the yellow line is the policies that give us also an opportunity, and the blue one are the strengthening of new technologies that allow us to have the same amount of movement in economy, in ships, in containers, but with probably zero pollution from CO2. Slowing down the speed to reduce shipping emissions. This is not very clear. I just tried to find some numbers here in this table that support this idea, but in the truth, in the reality, the world is not very convinced. Engineers, at least until I could study a little bit, they are not very convinced about this. Obviously, it is a kind of improving of the amount of energy that we are using in this kind of curve that we can see here. At the moment that you start to increase the speed, you start to also consume more and more and more fuel. That's obvious. And that's not what I'm saying. What I'm saying is that the naval engineers are probably not yet completely convinced that these reductions could help to save the planet. Why? Because there are some other ways. I mean, you can use small speeds, but your ship is not very well designed, so it consumes a lot of fuel also. But you can use very high speeds with a very nice old ship, and it consumes not that amount of fuel. So it gives some questions to have in mind. Other point is using renewable energy to reduce shipping emissions. Well, you can see here this kind of ship, which is using sails basically, but these sails are controlled by computer. This is not at all a new idea. This has been something that probably from the 1960s or something like that is being developed, but the world wasn't completely prepared for it. Now it is demanding to use it. So the idea is coming back, and it's almost prepared to go out. Taking incremental measures. This is what I was talking a little bit before, which is nice, better hydrodynamic shapes in the hulls of the ships, or to use, look at the ship, not plenty of sails, but a couple of sails. And these sails are also controlled by computer, and they are like going up and going down depending on the needs of the energy. Utilizing the battery storage, there is already a boat which is called Ampere in Norway, and it is really amazing to see these numbers, because this is the first all-electric ferry, cut shipping emission by 95% and cost by 80%. So it is really amazing, and it seems to be a very, very important proposal to reduce the emissions. Now, the speed is not that fast neither. It's probably about 5.5 kilometers in 20 minutes, which is covering. But this kind of boats, as you know, they are designed to cover short distances, so it's doing pretty well. This ship could replace a total of 40,000 truck journeys a year. Avoid shipping empty containers. Well, obviously, if we start to move containers with completely empty, well, we're losing energy, we're wasting immense amount of money, and we're polluting the atmosphere without needs. What to do? Well, I already said, like the carbon capture could be utilized and storage. In this situation, for example, you can capture this CO2 coming from transportation or coming from industry or from the atmosphere, and put it again in transportation. Could storage into land, special processes like opening holes into the earth and placing there the CO2, and then use it again, use it back when you can transform this kind of gases. There are also the way to manage the emissions and reduce the emissions and try to make more efficient the systems for engines. So you can use also the liquid natural gas, and all these together will give us a nice opportunity to also. In the shipping industry, it is important the use of space technology. So in this case, in Europe, they are using like measuring the amount of gases that is released by a ship, for example. By this tow ship, they can calculate the amount of gases and to know how to reduce, having this information, to know how to reduce this effect of the gases. Or now you know that the races, sailboat races, like the America Cup, they produce the most expensive technologies with just compared with the Formula One in cars technologies, which don't have a stop. They go without limits, and they have produced this kind of sails and this kind of overcraft boats, sailboats. Again, this is not completely new technology. This is basically the an airplane wing stand up. It's more or less that. It's a very old-fashioned technology, but with new applications. Again, and the kind of materials that are being used with over foil. For example, this kind of boats that you can see them almost flying over the sea. They can run really, really fast. And if you mix this kind of technologies, you can produce better boats or better ships if we are deciding to use this technology in the ship industry. So the reflection is like, what is happening with the industry of ships? That was what I have in mind at the beginning. I mean, this 3.0 very large container is the production of the CO2 emissions by a big ship compared with the production of air freight 747 with capacity of 130 tons. So they are completely different. They are not comparable, as you can see it in the graphic. However, from one moment to the other, we pass from being here as one of the less pollutants in the world in CO2 to now, which is like a great fashion, to be one of the great pollutants in the world in CO2. And for me, at least, it's a little bit hard to understand that. We pass from one point to the other in just a couple of years, and probably I could think it is related to how much is producing this industry. Remember that we move the 80% of the capital money in the world. So they can start to look at, these guys are wealthy, so they can help to solve the problem. But I don't know if the numbers in pollution are compared really. So conclusion are, no doubt, decarbonization is very important and we all should be contributing. But there are more questions than answers about it. The first step to IMO for GHG is to invest in research and innovation. Good political proposals, but not that good scientific evidence until the moment. Countries with low carbon emissions are treated equally as the ones with high carbon emissions. Create new indicators to low carbon emissions flagship countries. Create new indicators to low carbon emissions with high oxygen production countries. And in these two last, I am referring to Latin America countries. And to transfer efficiency decarbonization technology to low developing countries at low cost. And in this last one, I am referring to what we know that you are developing and you have in Dalian Maritime University, because it's obviously our reference university in maritime topics. And we will be very happy if we can get at some point to have information and could take advantage of the technology, your technological developments in order to decarbonize this industry. Thank you very much.
Okay, thank you, Prof. Reina, for the impressive speech. And the topic is really significant. In this speech, he pointed out that shipping liberates carbon dioxide and other greenhouse effect gases, which pollute the environment. And he also analyzed the occurrence of this phenomenon in Ecuador and some other countries such as LA, and observe different options to utilize the AI to minimize the risk of pollution. I believe both of the teachers and students have benefited much from it. And are there any questions about it? We can ask the Prof. Reina to discuss with he.
This guy, sorry?
Are there any questions about it? Dear students and teachers, and we can discuss with Prof. Reina about it.
I'm sorry, I'm trying to come back to my screen. But okay, well, these gases in general in the world are, the industry, the shipping industry is not the biggest pollutant industry in CO2 in the atmosphere in the world. And what I can understand at the end of this is why we suddenly start to be like the most important, or one of the most important in the world now, compared with terrestrial industries. So that is what I try to let you at the end as just an idea to think about.
Yeah, thank you. It's really a good and important topic today. And if the student or the teachers have questions, we can contact Prof. Reina by email. Thank the Prof. Reina again for today's speech. Ladies and gentlemen, I shall end here by thank you for coming to today's session of the Carbon Neutralization and the Green Shaping Forum. Thank you for your time and effort. See you tomorrow. Tomorrow's forum will begin at 8:30 o'clock. Thank you, Prof. Reina. Thank you for your impressive speech.
Thank you, Liang Hao, to you and to all our audience today. And my mail is open to answer any questions. Thank you very much.
Thank you today.
Thank you. Bye bye.
Thank you.
Bye bye.
谢谢。